Good morning, students. Yesterday, we discussed introduction on vector integration, and also I explained line, surface, volume integrals, and 2 example problems are done. So, today I will continue line integral problem. I am sharing the line integral problem document. Okay. Now we continue this problem. Yesterday I explained the statement of the problem. Once again, today also I explain the statement and the diagram. First of all, in vector integration, applying the line integration of the corresponding problem, first we draw the diagram. We draw the diagram is properly, then getting correct answer. If diagram not properly, the answer may be changed. So first we draw diagram is properly. Once we observe the statement of the problem, evaluate the line integral. Line integral means single integral at C. This is single integral at C. C means curve. This curve may be like this. So line integral at C. This is called the closed line integral. So closed means this curve C is maybe closed. Okay. So line integral x square plus xy into dx plus x square plus y square into dy, where C is the square formed by the lines, where C is the square formed by the lines y equal to plus or minus 1 and x equal to plus or minus 1. We draw the diagram using the given conditions. That conditions are y equal to plus or minus x, so plus or minus 1, and x equal to plus or minus 1. Okay. Every diagram we draw on 2 dimension. So this is the x coordinate, this is the y coordinate. Every diagram we draw on the 2 dimension. Given the values are y equal to plus or minus 1, that means y equal to plus 1 and y equal to minus 1, and also x equal to 1, x equal to minus 1. Identify the points of 1, minus 1 on y, 1 comma minus 1 on x in the 2-dimensional equation. This is the origin. Okay. And first, I identify the points of y equal to 1 and y equal to minus 1 in negative axis. Similarly, x equal to 1 and x equal to minus 1. Here, one statement is clearly given that in the problem, what is that? Where C is a square, C means curve. The curve where C is a square formed by the lines, that lines are y equal to plus or minus 1 and x equal to plus or minus 1. So using these 4 points, I form a square from the 4 corresponding points. I draw a line to the given points This is called a square. E square is curve C. Next, I identify some corner points named as A, B, C, D. Every time we calculate the line integral in anti-clockwise direction only. So first identify the A and next corner point B and next corner point C and next corner point D. Next we identify the corner points. That means here x value and y value. In the positive x equal to 1, every point we write in x comma y. So first we write x coordinate point and second we write y coordinate point. This is the merging point of x and y. Here x is positive 1 and y is also 1. So the point A is 1 comma 1. And similarly we write B point. Every point we write first x point. In the corresponding point line of x is negative axis, that is minus 1. This point of y is positive 1. Okay. And similarly, third point C. This is first negative minus x and negative minus y. Under D is positive x and negative y. So I am writing 4 points of the corner points of square. So now we calculate the line integral. So line integral C means line integral ABCD. The required curve is formed to a square. That square started from A and ended to D. So line integral C means line integral ABCD, and it is not possible to ABCD at a time. So we find first AB, then BC, after that CD, finally DA. So we splitting the line integral. First line integral AB plus line integral BC plus line integral CD and line integral DA. This is the required result of the given problem. So we calculate line integral, but here the line integral C is formed by a square. That square name as ABCD. We calculate ABCD is not possible to at a time. So we splitting the ABCD line integral. First we calculate AB, next BC, after that CD, finally DA. Adding 4 line integration of results, then we getting the required result. And again observe that first we taking AB, line integral AB. So here the point of A is here the point of A from the diagram 1 comma 1 and the point of B from the diagram minus 1 comma 1. Here observe that the x point 1 comma minus 1, here 1 in A and x point in B is minus 1. The points are different, and identify the second point, that means y. The point y in A and the point y in B both are same. So we fix in line integral AB y equal to 1. Why? Because we finding the line integral all terms x, y, z, all coordinate terms in single variable, because line integral calculating only single variable integration like as x integral x dx or integral y dy, integral t dt, integral theta d theta like as. So total variables are converted to single variable integral. So that's why I using the points from the diagram, I fix the constant value in a and b, y equal to 1. So y is converted to constant 1 and applying derivative dy. So dy means derivative of 1 equal to 0. So in the given problem, the contains x comma y terms, but in calculating AB, y equal to 1, dy equal to 0. So all y terms are converted to constants and remaining x terms. What is the limits of x? Observe that starting point A and ending point B, finding the AB line integral. So the starting point various points. So A equal to 1 to minus 1. So x is varies from 1 to minus 1. Okay. First, I calculate the line integral along AB. So line integral along AB means we calculate AB line. Observe that the point of A and the point of B, y is constant 1. So we fix y equal to 1, applying the derivative dy equal to 0. X is various, x point of A is 1 and x point of B is minus 1. So in the direction we observe the limits of x is 1 to minus 1. The limits of x is 1 to minus 1. So here y equal to 1, y equal to 1. We fix y equal to 1, applying the derivative on both sides. So dy equal to 0 and x is vanished from, x is changed in the direction A to B. So direction is most important. So x is 1 to minus 1. So the substituting these all values in the given problem. Now we substituting these values in the given problem. This is the limits of x. This is the substitution value. First of all, line integral along AB. So here already we discussed y equal to 1 fix, because y equal to 1 in AB, both points are same value. Applying the derivative on both sides, dy equal to 0. In A, x equal to 1. In B, x equal to minus 1. That is the variance value. So this is fix of the limits of x. X is varies from in the direction A to B. So 1 to minus 1. Substituting these values in the given problem. So the given function can be written as, generally we write x square plus xy dx plus x square plus xy square into dy. Substituting y equal to 1 and dy equal to 0, y equal to 1 and dy equal to 0 in this equation. So x square plus x into 1 into dx plus here dy is there. So dy equal to 0. 0 into something 0. So finally x square plus x dx. These all terms in x terms. So it is possible to apply the line integral C in the limits x equal to 1 to minus 1. So we calculate the integral of integral 1 to minus 1 x square plus x. integral of first term x square that equal to x cube by 3, integral of x that equal to x square by 2, substituting the given limits 1 to minus 1. First, substituting the upper limit minus 1 in x terms that equal to minus 1 whole cube that equal to minus 1 by 3 plus minus 1 whole square 1 by 2. This is the upper limit minus lower limit 1 by 3 plus 1 by 2. Now simplify this to getting the answer minus 2 by 3. This is only line integral of AB. Next, we calculate similarly line integral of BC. Now we are observing the line integral BC. So we calculate the line integral of BC. Observe that in the point of B is minus 1 comma 1 and the point of C is minus 1 comma minus 1. Here every point is comparing to general point x comma y. Here x equal to 1 is fixed. So x equal to minus 1 is a constant and a similar point in B comma C. And y is various in the direction B to C. So y value is various 1 to minus 1. So now we fix x equal to minus 1 in BC because it is same point in B and C. Suppose we fix x equal to minus 1, applying the derivative on both sides, dx equal to 0. So substituting these 2 points in the given problem, the problem all x terms are converted to x equal to minus 1. So x is converted to constant and dx equal to 0. So the first term completely is 0 and remainder term is 1 plus y square. So we finding the BC line integral, we getting all terms in y. So it is possible to applying line integral with respect to y. So line integral along second line integral BC. Okay. Line integral on BC. Here we fix x equal to minus 1 and x equal to 0, y is varies from. So this is the direction. Here y equal to 1, y equal to minus 1. We will finding this line. Okay. So y is varies from 1 to minus 1. The given function can be, given function means problem. So the problem, we substituting x equal to minus 1, dx equal to 0. When dx equal to 0, automatically the first term completely 0. In second term, dy, so replace x equal to minus 1 whole square plus y square into dy. So minus 1 whole square means minus whole square that equal to plus 1 plus y square into dy. All terms are converted into y. It is possible to line integral with respect to y. So I2 equal to first line integral I1, the result is minus 2 by 3 and I2 is line integral 1 plus y square. Integral of 1 into dy. So y, integral of y square, y cube by 3 and substituting the limits, lower limit 1, upper limit minus 1. We calculating these values, we getting the answer minus 8 by 3. So minus 8 by 3 is the second line integral value. Similarly, we calculate the line integral of C. Observe that the line integral CD, the point of C is minus 1 comma minus 1 and the point of D is 1 comma minus 1. Here y equal to minus 1 fixed and x value varies in the direction C to D. So x equal to minus 1 to 1 is the limits of x. When x equal to minus 1 fixed, applying derivative on both sides, dy equal to 0. So y is replaced by minus 1 and dy is completely 0. Substituting these values in the given problem, we getting all values are converted into x terms. It is possible to line integral with respect to x. So line integral along CD. Line integral along CD. Here we fix y equal to minus 1, dy equal to 0, x is varies from minus 1 to 1, replacing dy equal to 0, so this value completely 0, and replace y equal to minus 1, so x square, x into minus 1, so x square minus x into dx, integral, limits of minus 1 to 1, integral of x square, x cube by 3, integral of x square by 2, substituting lower limit minus 1 and upper limit 1. First upper limit minus lower limit. We are getting the answer minus 2 by 3. Next one, last one, the line integral along dA. So here x equal to 1, observe the diagram, dA. Here x equal to 1 in both points. So we fix x equal to 1, applying the derivative dx equal to 0. Here in the direction d to a, limits of y equal to minus 1 to 1. So substituting x equal to 1 and dx equal to 0, x equal to 1 and dx equal to 0. When dx equal to 0, the first value completely 0, and the second value replace x equal to 1, 1 plus y square. The resulting value of line integral dA is integral minus 1 to 1, 1 plus y square into dy. So integral of 1, so integral of 1 into dy, that equal to y, and integral of y square equal to y cube by 3, substituting the limits minus 1 to 1, we getting the answer 8 by 3. So adding, we require the line integral C, that means line integral AB plus ABCD, it is splitting to line integral AB plus line integral BC plus line integral CD plus line integral DA. We are putting the name as line integral AB is I1, BC is I2, CD is I3, and last line integral name as I4. Substituting all values in final integral I. First value minus 2 by 3, second value minus 8 by 3, third value 2 by 3, fourth value minus 8 by 3. Sorry, plus 8 by 3 cancel, plus 2 by 3 minus 2 by 3 cancel. Finally, the line integration of this pair is 0. So complete the line integration is line integral of ABCD, that means line integral C. When y equal to plus or minus 1 and x equal to plus or minus 1, it is formed by a square. The complete integration of this square resulting value is 0. Okay. Next, we are discussing problem number 2. The statement of second problem is, if f bar equal to 5xy minus 6x square into I bar plus 2y minus 4x into j bar, evaluate line integral f bar dot dr bar. It is the standard line integral formula. Line integral formula means line integral f bar dot dr bar. Remember it. So line integral means, every time line integral means, the standard notation of line integration is line integral of f bar dot d bar. General form of the line integration notation is line integral f bar dot dr bar. Okay. In the statement, we continue. Along the curve C in the xy plane and y equal z cube from the point 1, 1 to 2, 8. Here, no required a diagram because where C is not formed by a square or rectangle or triangle or any shape. Here, the points are given 1, 1 and 2, 8. So, calculate generally. Not required corresponding diagram. Okay. Given vector f bar equal to 5xy plus xx square into I bar plus 2y minus 4x into j bar. Consider, observe that in f is in terms of xy. So, generally R bar is xi bar plus yj bar plus zk bar, but here f bar contains only xy, so that's why I am assuming R bar also in terms of xy. Suppose you taking zk bar, so multiplying both functions, here no z term, no k bar, so 0 into k bar we write plus 0 into z, that is also 0. So it is not required. First of all, identify f in how many variables. In f has only two variables that are x, y. So I assume R also only xy in terms of xy. That's why R bar equal to xi bar plus yj bar. So dr bar, applying derivative on both sides, general derivative not with respect to x, not with respect to y. Generally, multiplying d on both sides, dxi bar plus dy j bar. So f is available given dr bar. Recently, we simplify. So in xy plane, observe that the statement of the problem where c in the xy plane. So that is also 0. F bar dot dr bar. F bar means this value. Dr bar means this value. So here observe that f bar dot dr bar means the quotient of I 5xy minus 6x square, the quotient of I and dr. So 5xy minus 6x square into dx plus 2y minus 4x into dy, because multiplying both functions with respect to dot I dot I1, j dot j1. Corresponding terms multiplication only possible in dot product, and remaining all terms are 0 because multiplying first term to second term, that is I dot j, 0. Second term to first term, j dot I, that is also 0. So in dot operation, we multiplying corresponding terms. Corresponding term means multiplying I terms and multiplying j terms and multiplying k terms only. So finally, f bar dot dr bar we write in the quotient of f bar 5xy minus 6x square I dot I1, the quotient of dr is dx plus the quotient of j bar in f for 2y minus 4x, and the quotient of dr, quotient of j in dr is dy. This is called the f bar dot dr bar. And given the problem y equal to x cube. Why? Because we calculate the given problem in the line integration. Line integration only possible to calculate the single variable function. So line integral calculating only dx dx or y dy or t dt or line integral theta d theta. So these terms are possible. Line integral x plus y into dx, it is not possible. So that's why in the given problem, two variables are given x comma y. So I converted either x into y or y into x because line integration only possible in single variable. So using the given problem statement, using the statement of problem, here y equal to x cube. The problem statement says that convert y equal to x cube. So convert y in x terms. So what about dy? Applying derivative on both sides. So dy equal to derivative of x cube 3x square under dx. So in the given problem, x and y both variables are available. So it is possible to apply the line integration. We must convert either x into y or y into x. But the problem says that convert y as a x, y equal to x cube is given. Now applying derivative on both sides, dy equal to 3x square dx. So I replace y by x cube and dy by 3x square in the f bar dot dr bar. So what about limits? The total problem is converted into x variables. So I taking the limits also x. So given the 2 points are available, the first point is 1 comma 1, name as A, and second point name as B. So observe that the total problem is converted to y. Now we are taking 1 comma 8 as a limit, but the total problem is converted to x. So we are taking the limits 1 comma 2. So 1 is the lower limit and 2 is the upper limit. Okay, first of all, we calculate the f bar or dr bar. Substituting recently finding values. So recently finding value means y equal to x cube is given and dy equal to 3x square dx. Substituting these values in f bar dot dr bar. So f bar dot dr bar means this equation. We substituting y equal to x cube and dy equal to 3x square dx. We getting the f bar dot dr bar. We getting f bar dot dr bar is 6 x power 5 plus 5x power 4 minus 6x square minus 12x cube. All terms are in x terms because dy is converted to x cube and dy is 3x square dx. These values replaces into y terms. So completely f bar dot dr bar is only single variable function, that is x functions. 6x power 5 plus 5x power 4 minus 6x square plus minus 12x cube into dx. We taking the limits also x terms. Observe that the 2 points are given 1 comma 1 and 2 comma 8. So the total function of f bar dot dr bar in x terms. So we taking the x comma x. In the point first value x equal to 1, in the second point x equal to 2. So the limits of the given function is 1 comma 2. So now by calculating line integral f bar dot dr bar that equal to 1 comma 2, this is the f bar dot dr bar. We finding the integration. So first 6 is constant. Integral of x power 5, x power 6 by 6 plus 5 constant. Integral of x power 4, x power 5 by 5 minus 6 is constant. Integral of x square, x cube by 3 minus 12 is constant. Integral of x cube, x power 4 by 4. So 6 cancel, 5 cancel, 3 in 6 2 times, 4 in 12 3 times. So the resulting value is x power 6, x power 5 minus 2x cube, 3x power 4 in the limits 1 comma 2. First, substituting the upper limit 2 in the given function, that equal to 2 power 6, 2 power 5 minus 2 into 2 cube minus 3 into 2 power 4 and minus 1. So we calculate the value, we getting the answer 35. So line integral f bar dot dr bar equal to 35. How to calculate f bar dot dr bar? F bar is given, but f bar is in terms of x, y, and I bar, j bar is available, not in k bar. That's why I wrote R bar also only I bar plus J bar. So R bar is available multiplying D on both sides. dr bar equal to dxi bar plus dyj bar multiplying F with respect to dot to dr. So F bar dot dr bar, but F bar dot dr bar in terms of x and y. It is not possible to calculate the line integral. So we convert x into y or y into x because but we given y equal to x cube in this statement of the problem. We using y equal to x cube, applying the derivative dy equal to x squared dx, the both values substituting in f bar the dr bar. After substitution, we calculating f bar the dr bar is completely converted to single variable x terms. Now we are taking the limits of x. Observe that the given points 1, 1 and 2, 8 identify the x limits. The x limits of first point 1, 1 x equal to 1 and the x limit of 2, 8 2. So the lower limit 1 and upper limit 2. Calculating line integral 1 to 2 f bar dot dr bar and substituting the limits, we getting the answer 35. Okay. Next problem number 3. The statement of 3 problem, a vector field is given f bar equal to sin y into I bar plus x into 1 plus cos y into j bar. Here also only two vector variable integrals I, j, not given k. Here also we taking r bar as xi bar plus yj bar, not zk bar. So evaluate, continuation of the problem, evaluate the line integral over a circular path is given by x square plus y square equal to a square at z equal to 0. Here we require a diagram because x square plus y square equal to a square is the equation of a circle. So we are taking the circle equation at z equal to 0. In xy plane automatically z equal to 0. First of all, we calculate the line integral formula. Line integral formula means line integral f bar dot dr bar. F bar already given in the statement of problem, that is sin y into I bar plus x into 1 plus cos y into j bar. We find out dr bar. Dr bar, we know that the fixed value r bar equal to xi bar plus yj bar plus zk bar, but zk bar not taken. Why? Because the problem F contains only ij. That's why I assume R bar also ij terms. That equal to R bar equal to xi bar plus yj bar. Suppose the F has K is a vector coefficient, then I take R bar is xi bar plus yj bar plus zk bar. But F has no K bar. That's why I assume R bar also no K bar. Multiplying d on both sides, dr bar equal to dxi bar plus dyj bar. Okay, so f is given, dr bar recently we find out. So multiplying these functions corresponding to the dot. So applying the dot product, multiplying the corresponding terms only. So in f bar, the quotient of phi sin y into dx. The quotient of j, multiplying x inside x plus x cos y into dy. This is called f bar dot dr bar. So we calculate this problem into line integration. But it is not possible to solve line integration because line integration must contain only single variable. Here x and y both variables are available. Now we convert x into y or y into x from using the statement of the given problem. The given problem statement is x square plus y square equal to a square. Using this statement, we convert x as y or y as x. So after f bar dot dr bar, it is possible to calculate. So sin y dx plus x cos y dy plus x dy. So observe that derivative of x sin y, derivative of x sin y, general derivative UV formula, applying UV formula, x is constant, derivative of sin y cos y and derivative of y dy plus sin y is constant, derivative of x dx, not with respect to x, with respect to y, general applying derivative. So first is x is constant, derivative of sin y is cos y and derivative of y is dy plus sin y is constant, derivative of x dx. Here x cos y dy plus sin y dx, x cos y dy sin y dx, it is two terms. It is possible to write derivative of x y. It is simply calculate the one type of differential. It is shortcut to getting the answer easily. So observe that here x cos y dy plus sin y in two terms we write a single term. That is the derivative of UV formula. So derivative of x sin y equal to x cos y dy plus sin y into dx. We write these two terms into single term, derivative of x and y, and x dy is same. Okay. Next, we taking the diagram. For example, x square plus y square equal to a square in xy plane. This is the x square plus y square equal to a square equation. So the given path, circular path x square plus y square equal to a square z equal to 0, we assume that in already we know that the multiple integrals we discussing x equal to a cos theta, y equal to a sin theta, and dx equal to derivative of x minus a cos theta derivative minus sin theta d theta, dy equal to a sin theta derivative cos theta d theta. So substituting all these values in the problem about the dr bar. Why? Because it is not converted x as y completely or y as x. It is not possible to convert x in terms of y or y in terms of x. That's why both two terms are converted into theta. It is possible to calculate the line integral. Only single variable is possible. In last problem, we convert y in terms of x, but this problem, it is not possible completely y in terms of x or completely x in terms of y. That's why I taking x in terms of theta and y is also in terms of theta. So the total problem about the dr bar is completely converted to single variable theta. It is also possible. So I write x equal to a cos theta by using the equation of a circle. This is the standard value. Already we discussed in M1 multiple integrals. So derivative of x dx equal to a is constant, derivative of cos theta minus sin theta, and derivative of y dy equal to a is constant, derivative of sin theta equal to cos theta. Substituting these all values in a bar dot dr bar, and the complete circle, the limits of the circle 0 to complete circle is possible when 2 pi 360. So the limits of theta, angle of theta of the complete circle is generally 0 to 360. So the limits of theta equal to 0 to 2 pi in the diagram of circle. Okay. Theta is varies from 0 to 2 pi. All x, y, dx, dy is converted to theta. Substituting all values in above the dr bar and simplify it, finally we getting integral 0 to pi a square cos square theta d theta. In integral, cos square theta has not direct formula. I converted cos square theta. I write the cos square theta in trigonometry formula. That is cos square theta equal to 1 plus cos 2 theta by 2. So to separate the integration and d theta to 1 by 2 and cos theta by 2. So substituting the integration and calculating the integration and substituting the limits 0 to 2 pi, we getting the answer pi a square. Okay, these are 3 problems. Once again you do these 3 problems in afternoon section.